This is for Year 12 Methods Functions part of Chapter 1. It's 1F Inverse Functions, question number 14. So in question number 14, I've got g of x with a restricted domain from b to infinity, where g of x is this parabola. Find if b is the smallest real number such that g has an inverse function, then find the value of b and find the equation of the inverse. Okay, so I've got y equals x squared plus 4x. So this has a y-intercept of 0. And if I want to find my x-intercept, 0 equals, I can factorise this x plus 4, goes through at -4 and 0. So it looks like this. And at the moment, this function is a many to 1, therefore its inverse will be a 1 to many, and as such will not be a function. Its inverse would look something like this. Therefore, it's not going to be a function. So I've got to restrict the domain so that it is 1 to 1. So I could get rid of this and all of this to the turning point, and that would make g a 1 to 1. I could even go further than that, but if I went further than that, then my value of b would be this value of x here, and that's not the smallest. So I'd like to restrict my domain back to the turning point. So I'd like that to be the value of b, and therefore I will have the function being a 1 to 1, but b being the smallest possible real value. Now that's going to be dead middle between the two x-intercepts, therefore b equals -2. And my inverse function will look something like that, where if I put a -2 in there, 4 minus 8, that's going to be at -4. So -2, -4, -4, -2. So b equals -2 is going to be the value of my domain commencement value. So to work out the equation of the inverse, I've got y equals 4x squared plus 4x. Swap x equals a y squared plus 4y. Now when I've got y's appearing in two spots and I wish to consolidate them and I have a quadratic, I'm going to complete the square, which will consolidate down to 1y. So x equals y squared plus 4y, half of 4 is 2, 2 squared is plus 4, and then minus 4. These three become y plus 2 all squared, minus 4 is equal to x, and now solve for y. So x plus 4 equals y plus 2 all squared. Y plus 2 will equal the plus or minus square root of x plus 4, and when I move my minus 2 over, minus 2 plus or minus the square root of x plus 4. But because my domain has resulted in my inverse having a range going from -2 to infinity, therefore I want the positive square root. So the inverse of x is equal to -2 plus the square root of x plus 4, and that gives you a b equaling -2 in the domain of g.